Okay, so for this example, we're going to suppose that 200 randomly selected cancer patients were asked if their primary diagnosis was brain cancer, yes or no, as opposed to some other kind of cancer, and if they owned a cell phone and used a cell phone before their diagnosis. So we can see sort of the results here, the number that sort of fell into each of the categories. Maybe I'll draw some lines on here to make it more clear, right? Here we go. The numbers are kind of weirdly spaced, aren't they? But the key here is that this 200 here, that is fixed. We knew ahead of time we were going to ask 200 people, okay? And the values here that show up for the number who have brain cancer or not, or the number who have who use cell phones or not, that is simply random based on the sample that we got. But it's this total that's fixed, which means that if we're going to test whether or not there's association, we're doing a test of independence here. Okay. All right. So if we wanted to test whether there's an association here, okay, maybe I'll just write down explicitly the null and the alternative hypothesis. So the null is that there is no association between the two variables. So there's no association between cancer type and cell phone use. Maybe, sorry, I think I said specifically ownership, so I better say that and spell it correctly too. Okay, so that would mean that they're totally independent from each other. Okay, knowing whether or not someone owned a cell phone or not is going to have no impact on their probability of getting brain cancer, as opposed to other cancers. And the alternative hypothesis is that there is an association. And if you were being really precise, you might say between the cancer type and cell phone ownership. Okay, so that's the null and the alternative. Okay, to get our test statistic, it's going to involve quite a bit of calculation here. So just to remind you, the test statistic for these is always the sum of the observed minus the expected squared divided by the expected for each of the different cells. Okay, and let me just color code here. So these here that are given, those are the observed values. And then what we need to do is we need to calculate the expected values. So let's just go through that for one of these cells. So let's talk about this first cell here, the yes cell. So it's always going to be the row total. So in this case, it's 98 times the column total, which in this case is 25, divided by the overall total, which is 200. And let me just see if I can pull up and calculate that. So that gave me 12.25. So let's do it for one more cell here. So for this cell, the yes cell phone, no brain cancer cell, we've got the row total times the column total divided by the overall total. And when I do that, I get 85.75. And I'll just work it out quickly. We get 12.75 for this expected value of this cell. That would be 102 times 25 divided by 200. And then our last cell, we do 102 times 175 divided by 200, gives me 89.25. Okay, so each of those there, those are the expected values for each of those cells. Okay, once we have those, we're just going to plug them into our formula here. So bear with me while I write this all down. We've got our observed, which is 18, minus our expected, which is 1225. We square it and divide by our expected, 1225. So that's for our first cell. And then we've got the next cell, which is are observed, which is 80 minus 85.75 squared divided by 85.75. Our next cell is 7 minus 1275 squared divided by 1275 plus and 95 minus our expected 89.25 squared divided by 175.